Hello everyone, I'm Dave Thomas, and today we're doing the third rocket in the Orion 3D series. This one is the Bellatrix. This uses a 13mm motor, and like all of these, you have to have a 3D printer in order to make the fin assembly, the coupler, and the nose cone. So when you buy this kit, what you get in the box here are the tubes and motor mounts and everything for these rockets. And then Estes will email you a link where you can download the printer files for all the parts as well as the instructions. Okay, so the instructions are not in the kits that are in here. You have to download those. So here's the kit package for the Bellatrix, and we'll just open this up here. Okay, now using my downloaded instructions here, we'll go ahead and check these off. So we've got a motor mount tube, a streamer, and you may want to elongate this, I probably will. Engine retainer clip, shock cord, centering ring, it looks like a sleeve, okay, two body tubes that should be identical. Okay, decal set, and then the other centering ring and the engine block. Here are the 3D printed parts for the Bellatrix, and I've got two sets here. So up here in the instructions, kind of in the upper right, we've got some recommendations for 3D printer settings. Now I'm using a Dremel Digilab 3D45, and it's a nice printer in that it's fairly idiot resistant. It has a lot of built-in features that are good if you're a novice and really don't have a lot of experience with this, and that includes me. But you can get deeper into the settings and change things around as you need to. Alright, so the wall line count, they recommend 2 to 3. I actually used 4 for both of these sets, and that just gives a little sturdier edge. Now the infill density, on the pink ones here, I used the recommended setting here at 10%. And I also, what they don't show here is I used a line thickness of 0.1 millimeter, which is the finest that my printer will go. On this set, I used a line thickness of 0.2, so it's a little coarser, and an infill density of 50%. Now for the fin can here, that doesn't make a lot of difference because most of this is not going to be infilled anyway. It's mostly solid. But if we look here, this should have more detail and a smoother finish, but for some reason it does not. Okay, we get these areas where essentially there's no outer line in here, and we're seeing the infill. I haven't done any chemical treatments to these. All I've done is a little bit of trimming with a hobby knife. But overall, what should have had a smoother finish to it doesn't. Okay, if we look at the nose cones, they're close to the same. It's kind of hard to see the detail on the yellow one here. This one also has 10% infill and a 0.1 millimeter line. This one is 50% infill and a 0.2 millimeter line. Okay, they're not that different in weight. In fact, let's pull up a balance here and take a look at them. All right, so here's my pink one. All right, with 10% infill, about 6.5 grams. Okay, about another 4 grams of weight there. If we look at our fin cans, come on, tear. There we go. Alright, with 10% infill, 100 roughly, well, it's not 100, about 13.6. With the 50%, about 15.3. Okay, so the yellow set is a little bit heavier. The couplers here, that's what fell on the ground. Okay, same settings as the other ones in their color. These you don't see, so it won't make a whole lot of difference as to what they look like. Okay, so what I'm going to do on this one, just to be a little bit radical here, I'm going to use the yellow fin assembly, the pink nose cone, and then whichever one of these fits better. Now those potential problems that we saw with the 3D parts are really why this is set at as an intermediate skill level. The rocket parts here go together like most basic rocket kits, but you may need to troubleshoot the 3D printing, and that's probably where a lot of your time is going to be put. Okay, so for our first part here, we are going to cut a slot in the motor mount tube at 1/2 inch from one end, and then that end will become the forward end. So I'm just going to take my ruler here and my pencil, okay, and from one end we will mark 1/2 inch. Okay, and then I'm going to take my hobby knife here, and we're just going to cut a slot that's wide enough for the clip to go in. So that's going to go in just like that. Okay, and then we're going to measure 1 inch from the forward end. Get turned around the right way here. Alright, or if you're metrically inclined, about 2.5 centimeters. Okay, and then we're going to come back here. Take this sleeve here. Okay, and that's going to, all this sleeve does is help hold that clip in place. So it's going to go down. Looks like it's actually going down to about that far. Okay, so the mark will be at the forward edge of that. And here we'll just take a little bit of wood glue or white glue and just make a thin bead here. It doesn't take a lot, that's more than what we need. Alright, and just slip this through the glue and down to that mark. Already being kind of grabby there. Huh? Come back up. There we go. Alright, and just wipe away any excess glue. Alright, then we're going to take our thrust ring here, and this is going to go down inside this tube and rest upon the engine clip. Okay, so this is getting kind of small for my big fingers. Alright, so it's going to rest like that. Now they show putting the glue in the tube and then this through it. And this is what you would normally do for couplers and things like that. The problem is if you put the glue in first and then shove this down, excess glue goes down inside here, and that could potentially cause a problem with the mounting of the motor. So instead, on this one, I'm going to apply a bead of glue to the ring itself. Okay. And then you can actually just put that down on the surface, put the engine mount over that, and then push it down until it rests upon the engine clip there. Now make sure it's level. You don't want it pushing down opposite the engine clip, which will often happen. So make sure that's level inside there. Okay, and now we need our centering rings here. We're going to cut a notch into one of them to leave room for the engine clip. So just cut down through there, and then another one that's about an engine clip's width, about like that. All right, now it does kind of fray there. We'll be able to fix that here in just a bit. Okay, so the one we haven't made the slot in, that's going to go up here right at the engine clip. So we're just going to put a bead of glue here. Okay, and then this will go on over that, through the glue, and right till it rests upon the clip. All right, and then you can just smear a fillet there with your fingertip. And then, let's see here. Okay, the split ring now is going to be flush with the aft end of the motor mount. All right, and our clip will be in there like that. So here, we'll go ahead and put another bead of glue on this. Try to avoid hitting the engine clip. Alright, smooth that. We don't want big globs on there. Kind of smooth that in. Okay, and then we'll put this on into the glue. Okay. And I am going to put a small piece of masking tape on there to hold that ring in place while the glue dries. Now, once it does dry in there, if you're finding that the edges here are trying to fray up, you can put just a drop of regular super glue on that, and that will re-laminate it together basically. Alright, so I'm going to set this aside to dry. While the engine mount is drying, we can couple the tubes together. And I have two couplers. I had the pink one and the yellow one. This one actually fits a little more snugly, so I'm going to use that. And they have us using super glue, CA glue. And for that, I'm going to use a gel type rather than the runnier type here. As I found this works better for joining two surfaces of different types. Now, before I stick that in there, we do need to find the midpoint on this. So that's about a little over 3 centimeters there. We'll call it about 1.6 for the middle. Okay, actually a little more down that way. Close enough. Alright, so now in one tube we'll run a bead of glue. Alright, and put this into the midpoint. Kind of twist it in as we go. Alright, and we're going to do the same thing with the other tube. We'll put another bead of glue in here. Now when we put this on, hold some pressure down here where the coupler is inside the tube so that you don't push the coupler further in. And we'll just add this. Alright, if you want, you can align the spirals. It won't make any difference. Okay, and we're going to let this dry. As I thought about this further, I decided I'm going to use all of the same batch for the pieces here. So I was going to put the pink nose cone on in place of the yellow one, but the yellow one weighs more. And so in order to make sure that the balance and center of gravity are well ahead of the center of pressure here, we're going to use the same density parts. Alright, we are ready to install the engine mount. So we'll just peel that away a little bit. Okay, and I think that's going to be okay all by itself. So we're going to do a test fit here first of all. Alright, we want to make sure here there's nothing to worry about. Alright, so typically I put in my engine mounts so that the engine clip is in line with the launch lug. Now that is just a little bit snug there. Okay, now there may be a lip. Yep, there is. Alright, so that's what's preventing it from going in. So to fix that, I'm just going to take a little bit of 100 grit sandpaper here and just run that around the inside. Okay, we'll try this again. Almost there. It's really, really snug. So we'll give it a little more sanding. Okay, I'm running into another stop here. I think, hopefully you can see that movement inside. It's like there's a little bit of a constriction in there. I'm not sure why it's there. We'll see if we can remove that as well. Fortunately, PLA sands really quickly. Alright, one more time here. Okay, I cannot reach any further in. Let me try it from the forward end here. The problem with doing it from this end is it's already narrow here and it's widening out, so it's going to be hard to get the friction of the sandpaper up against it. Kind of tilt things as I rotate. Okay, so that'll go in, but I'm going to have to force it a little bit. Okay, now what they're showing here is to put a ring of CA glue just at the opening of the body, or not of the body tube, but of the fin can. The problem if you do it this way is basically all the glue is going to end up on the forward ring and it's going to push it forward. So what I'm going to do here is take my gel type cement and I'm going to reach it down as far as I can and apply some glue up inside there. So you're not going to be able to see this part, but it's happening, we hope. Okay, actually that came out fairly even, so you can just see it down in there. Okay, so I'm going to poke that in. And now I'm going to apply some more glue right inside the opening here. And you can kind of tilt this out of the way as needed. If you get a little bit on the motor mount tube, it's not a big deal. Alright, I think we'll go with that. And again, I'm going to rotate mine so it's in line with the launch lug. And we're going to press that flush there. Okay, so it should look like that when we're done. I'm going to let that dry for a few minutes. While the glue is drying inside the fin can, we'll go ahead and do the shock cord mount here. Cut this out. Okay, Now, the typical Estes shock cord mount is what they show here. And you take the shock cord, alright, and you smear this whole thing with glue. You put the shock cord down the middle, and then you'll fold the first flap over the second over the third. And all the while you've got glue in there. That works except for you've got the shock cord here going over here, and that makes a bulge into the inside of your body tube. Now if you got a big body tube, it's not a big deal, but we've got a fairly narrow one, and this could interfere with how the parachute, or in this case the streamer, deploys. Now a viewer taught me this trick, and I really like this. So what we do here is take and cut a fork into about the first inch to inch and a half of the shock cord there, and then we're going to lay this down across section 2 like that. And now when we fold this over, these two forks will go on either side of the main part of the shock cord rather than on top of it. Okay, so a little more wood glue here. You can also use white glue for this. Okay, and we want this spread pretty evenly all over, because in the end what we're going for is a sandwich of glue and paper with the shock cord caught in between and not a lot of air bubbles. Okay, so I'm going to kind of lay out the forked area there. Okay, and then we'll just fold the one over the two, squish out the air, 2 over the 3. Okay, and you can kind of squish this around so that the forks are indeed on either side. Alright, I'm going to curve this a bit so that the convex side here is what's going to get glued to the inside of the body tube. Add a bit more glue here. Now again, you want this as a nice even coat, not with big globs in it. If you get too much glue, it saturates the paper and it falls apart. Okay, and now we want to put this down at least 1.5 inches down the body tube. And that much clearance is required in order to prevent it from hanging up on the nose cone. So I'm going to kind of slide that in and then use my little finger here to get that down as far as you can. If you've got long skinny fingers, go for it. Take that even further down. Okay, I'm going to use my pencil here as my fingers don't quite fit, and I'm just pressing this against the inside of the tube that I'm supporting with my hand. Okay, so that, I don't know if you can get quite down there or not. Alright, but that's squashed up against there with not a lot of things poking into the inside of the body tube. Now we can come back to the other end where we should be about ready to add our fin assembly. I'm just going to do a dry fit first. Okay, so that should go right up against this little taper here. Okay, to glue this in, we're going to use the thick CA glue again. And just start by running, my bottle's almost dry, run a bead here just inside the body tube. Okay, and then just twist this on as it goes in. Okay, and once again, we're going to let things dry. Coming back to the forward end of the rocket, we're going to attach the other end of the shock cord to the nose cone and just tie a double knot here, or 2 half hitches. Okay, and then just pull that from all directions so that it's snug, and then cut back this free end here to about 1/4 inch or about 5 to 6 millimeters there. And then take just a little tiny dab of white or wood glue and apply it to the knot. Alright, we'll let that dry. For the streamer, we've got this. Now, my understanding of the engineering and physics of streamers and everything, which comes mainly from the R.E.A.R handbook and a few other rocketry guides, they indicate that the optimal streamer size is 20 times its width. Okay, so if this is a 1-inch streamer, it's got a width here of about 19 inches. All right, so it's pretty close. I'm going to put a longer one on here, mainly just because I can, and it's going to be more visible and look cooler and everything. And mine will actually be lighter. So this is flagging tape. You can find this at most hardware stores. And it's a thinner thickness than what they sent us in the kit. And so we can actually use a lot of this. Now, there are some who say that if you use too much, it actually loses its ability to slow down the rocket. So we're not going to get too carried away here. I'm going to go with, say, a 40-inch streamer. Okay, so about that much. Okay, now some people like to tie their streamers on, others like to tape them. My personal preference is to use a little bit of electrical tape here. So what I'll do is just peel off about 1 inch length or so. Maybe a little more, just about that much. Okay, and I'm going to put this onto the streamer, not quite halfway up, like this. And then I'm going to come down. The length doesn't have to be exact, you know, say 10 centimeters or so, 4 inches, around that area. Okay, I'll put that on, and I'm going to fold the tape over everything. Like that. And just give it, squash it down there really good so it adheres well. Okay, now we're pretty much ready to put this all together. So if you're prepping this for launch, you'll probably want 2 pieces of recovery wadding down inside there. Now to put this together, I'm going to take the streamer and first just run it up on itself here. So I'm going to fold it lengthwise over itself. And I'm going to do this several times to get it down to a manageable length. What you don't want to do at all, never ever, is wrap it around the shock cord because it won't deploy. You'll just get a few unravelings and you get a really tiny streamer that way. All right, but instead, just keep folding this over itself until you get to the point where now it's manageable. I'm going to go, actually, one more there, and then I can roll up the rest like that. Okay. Now go ahead and shove this shock cord down inside there. So we can do this without getting it all tangled around itself. Again, this is a fairly small body tube. It's a BT20, so if you've got long, skinny fingers, this is easier to do. Okay, and then we're going to take the streamer and push that down, and this should go in easily. If it's encountering a lot of resistance, check and make sure that your shock cord mount didn't come dislodged or is bulging out. Alright, and then just slide in the nose cone. Okay, now that, alright, so normally what we'll do here is we'll do a shake test, and you don't want the nose cone to shake itself out. But if we do a pull test here, that should come out with very little force. And this is going to require a little bit of sanding here. Okay, now this is going to require enough sanding that I'm going to have to detach the shock cord here. Well, I just broke it. Well, that's another way. Okay, so I didn't want to do it with the shock cord on because I would end up sanding the shock cord, and that will definitely cause a failure. Alright, so here I'm just going to take the sandpaper. This is 100 grit, and I'm just going to sand down the shoulder a bit here. So ideally I should have tested the nose cone fit before I put the shock cord on. Some people say I might be getting old and senile. I can't remember who said it though. Alright, I'm going to shove that down out of the way for the moment. There we go, that's better. Okay. So now if I stick that in there, I'll go ahead and do the shake test again. Alright, still not shaking out, alright, but I can easily move it forward with just a few fingers of tension there. Okay, so now we'll go ahead and attach that back on. There we go. Okay, and once again I'll go ahead and glue that back on. We'll give that just a few minutes to dry before we put it all together again. Now that the last bit of glue has dried, we can go ahead and put this back together. Okay, and again, make sure we don't trap any shock cord in there. Alright, and now we just have a decal. Alright, I'm going to try and center this over that seam and on the opposite side from the launch lug there. Okay. It's a good idea to wash your hands first to help kind of minimize fingerprints. You won't get rid of all of them, but you can try. Lay this down just very gently at first. Alright, make sure you get it as straight as you can get it. Sometimes you can re-lift it, but a lot of times it'll just pull up this finish. So I think that's pretty close to where I want it. If you've got it then, go ahead and smooth it down, starting from the center and working your way toward the edges. Remove all of the air bubbles there. Okay, and then we've got two Estes logos. They're not going to go on the 3D printed parts very well. So for mine, I'm just going to put one down here near the fin assembly. And the other up by the nose. Alright, and then from nose to tail, that's my Bellatrix. I hope you had fun building this with me. Have a great launch and a safe recovery, and please stay tuned for more of my videos.